Having seen our objectives for the class, let us therefore go down to the fundamental topic for the day, stoichiometry. When we think about stoichiometry, it is actually a word which originates from the Greek word stoichion, which means element, and metron, which means measure. So literally, we can say that stoichiometry is the study of the measurement of elements, how elements are measured. So, having seen that, let us get to understand the in-depth of what stoichiometry really is. Stoichiometry can therefore be defined as a branch of chemistry that involves calculations and expresses the quantitative relationships between reactants and products in any given chemical equation. So, what it simply tells us is that whenever any chemical reaction takes place, the reactants and the products are related by certain quantitative relationship. Looking at the equation on the board, it tells us that 1 mole of methane, CH4, reacts with 2 moles of oxygen to give us 1 mole of carbon dioxide and 2 moles of water. So this is an example of the relationship between reactants and products. So looking at what we have here, if the equation isn't balanced, then it ought to be balanced so we can get to understand the quantity of reactants that came together to give us the quantity of products we are having. So this is what stoichiometry is all about. Talking about stoichiometry, let us get to simply understand that reactants and products must have some kind of relationship. Before a reaction takes place, there will be some amounts of reactants. And after the reaction, the quantity of reactants must have reduced. If there are 2 quantities of reactants, it may have reduced to 1 or even half what it was before. So it simply tells us that the quantity of reactants that has been reduced led to the production of the quantity of products we are having at a point in time. So talking about this relationship, let us get to understand more about the mole relationship of reactants and products. So we are going to be looking at mole ratio. When we talk about mole ratio, what do we really mean? The mole ratio is that relationship in which reactants combine with products. That is to say, the mole ratio in which reactants and products are made to come together gives us that thing that tends to balance the equation. Take a look at the equation displayed on the screen. We have nitrogen reacting with hydrogen to give us ammonia. Looking at the equation, it is clear that that equation is not balanced. So how do we tend to balance such equations? To give such equation its mole relationship, let us tend to balance that equation. We are going to learn balancing of equation as we proceed in this lesson. So, looking at the equation, we have nitrogen plus hydrogen giving us ammonia. Since it is not balanced, in every reaction, the species are meant to be balanced. That is, all reactants are meant to be balanced with the products. So, to balance that reaction, as we can see, we can choose to put 3 hydrogens there and 2 in front of ammonia. This gives us a balanced equation. So it simply tells us that 1 mole of nitrogen, whenever ammonia is to be formed, will need 3 moles of hydrogen. and that will give us 2 moles of ammonia. So hydrogen is always in a mole ratio of 3:1 with nitrogen in any given reaction between hydrogen and nitrogen to form ammonia. Looking at the second equation between hydrogen sulfide and oxygen, the equation isn't balanced and ought to be balanced. So if we are to balance that equation, we have hydrogen sulfide plus oxygen. That gives us water plus sulfur 4 oxide. To balance that equation, it is simply to put 2 in front of hydrogen sulfide, and we have 3 in front of oxygen, and this gives us 2, and we have 2 in front of sulfur 4 oxide. So to look at the equation, we have 2 moles of hydrogen sulfide. We need 3 moles of oxygen gas to give us the products we have here, 2:2. So it simply tells us that this is the mole ratio in which hydrogen sulfide must combine with oxygen to give us our desired product. And the numbers are referred to as mole ratio. The coefficient numbers are referred to as mole ratio. So this is what we refer to as the mole ratio of any given equation in stoichiometry. The last equation, if we are to balance that, is hydrogen sulfide still with oxygen. That can give us water and sulfur when oxygen isn't abundant. And for that, we have 2 and 2. Lastly, we have 2 in front of sulfur to balance that equation. In this reaction, this is the reaction of hydrogen sulfide with oxygen when oxygen is limited in supply. So when we have limited supply of oxygen, it's not going to give us sulfur 4 oxide. Instead, we're going to have sulfur as the product. And if we are going to have sulfur as a product due to limited supply of oxygen, it means 2 moles of hydrogen sulfide will be needing 1 mole of oxygen to give our sulfur product. 2 moles of sulfur and 2 moles of water. So this is what we refer to as mole ratio. Having seen that, let us proceed to our next discussion. It is more convenient to interpret the coefficients as number of moles. That is to say, the numbers in front of these reactants and products. It is more efficient, convenient for us to refer to them as number of moles, because in stoichiometry we measure amount of substance by grams, and grams can be converted to mole using the formula mole equals mass over molar mass. And this is the absolute relationship between mole and mass. Let us take a look at some quantitative measurements and their units that are of utmost importance in stoichiometry. Some of these quantities are mass, molar mass, volume, molar volume, amount, which is mole, molar concentration, mass concentration, Avogadro's number, and number of particles. Mass is having a symbol m, and its unit is gram or kilograms. Molar mass is measured in gram per mole. Volume can be in cm cube or dm cube. Molar volume is dm cube per mole. Amount of substance is in mole with the symbol small letter n. Molar concentration, also referred to as molarity, is in mole per dm cube with the symbol m or c. Mass concentration is measured in gram per dm cube with the symbol P, and Avogadro's number is per mole with the symbol L. Lastly, we have number of particles, which is just a number, and it's represented with the symbol N.